Hey guys, welcome back. And today we're going to be getting into the sum and difference identities, which is 7.3. And just real quick for the think/warm up, I have used the graphs of sine and cosine to help you understand why the sine of negative a equals negative sine of a. Let's do that one first. And I'm just going to very rudimentarily sketch the graph of sine, right? And so when we think about it, if this is a, this would be negative a, right? And so sine of negative a is -1. Well, sine of a would be 1, but if we put a negative out in front of it, that makes it -1, right? So it's kind of like we have this opposite thing going on the whole time, right? Here and here. Here we're at -1 and here we're at +1. So just kind of taking away, right? If you look on the other side of the positive a and you just make the value negative that you get in the end, that's kind of what's going on here. And if you do that with cosine, well, let's think about cosine real quick. Cosine, you start up there, and then you also go down like that. And cosine kind of mirrors, right? It's like a reflection on the y-axis. So, if you're at cosine of a, then cosine of negative a are both going to have the same value, no matter where you're at, right? Here and here have the same value all throughout. So that's why that kind of works there. Not really related particularly to this lesson, but just previous things to think about. And so here's our sum and difference identities, and I shouldn't have done that in blue, but there is one little typo. There should be an a or an alpha plus or minus beta there. And here, if you haven't done so already, you're going to want to write these down, right? I gave a whole list of all of them. If you have that sheet printed out, you're fine, but if you don't have that sheet printed out or you didn't write it all down before, you definitely want to write these ones down for this section. And here I have showed that cosine of x plus y does not equal cosine of x plus cosine of y by producing a counterexample. Well, let's just pick some numbers to work with. We could say x is pi thirds and y is pi 6, right? We're just trying to show a counterexample. Any would probably work, so I'm just picking nice radians that we're used to working with. So cosine of x is pi thirds plus y is pi 6 equals cosine of pi thirds plus cosine of pi 6. Pi thirds plus pi 6, this will be 2 pi over 6. 2 pi plus pi is going to be 3 pi divided by 6. 3 divided by 6 is 1/2. So really, we're going to have cosine of pi halves. And then here, cosine of pi thirds, remember pi thirds is 60 degrees. So that'll be square root 3 all over 2. Plus cosine of pi 6, that's 30 degrees. Cosine of, I was thinking sine. Cosine of 60 degrees is 1/2, and cosine of 30 degrees is square root 3 over 2, right? Cosine pi halves, if we think about our graph, right? 2 pi's there, pi halves is here, so that's 0. Cosine of pi halves is 0 equals 1 plus the square root of 3 all over 2, and hey, those don't equal, right? This was like really a question the whole time. Are those equal? Nope, those are not equal, so we just showed that this is not, or that cosine of x plus y does not equal cosine of x plus cosine of y by producing this counterexample of these two. Moving on, use the sum or difference identities for cosine to find the exact value of cosine of 735 degrees. So we're going to be using this identity here. And before we do that, cosine of 735 degrees, we can reduce that to cosine of 15 degrees, right? Because 360 plus 360 is plus 15, right? Maybe I should write this 360 plus 360 plus 15 is 735. So really, cosine of 735 degrees is going to be the same as cosine of 15 degrees. Now this is a little tricky. Using the sum or difference identities, we don't know what the cosine of 15 degrees is off the top of our heads. We're trying to find an exact value. And in order to do that, we need to think of things that might add or subtract, right? Sum or difference that might add or subtract to 15 that we do know. And some exact values that we do know, one would be 45 degrees minus 30 degrees, right? That equals 15 degrees. That's the same thing. And we know what 45 degrees and 30 degrees are. But now we have to use this identity here, right? This cosine identity that we see in the middle. And when we do that, we're going to get the cosine of 45 degrees times the cosine of 30 degrees plus the sine of 45 degrees times the sine 30 degrees. Cosine of 45 degrees is square root 2 over 2 times cosine of 30 degrees is square root 3 over 2 plus sine of 45 degrees is also square root 2 over 2. Sine of 30 degrees is 1/2. Square root 2 times square root 3 is square root of 6 all over 4 plus the square root of 2 all over 4. And we can just combine the tops there, the numerators. There we go. So the cosine of 50 degrees, the exact value is square root of 6 plus square root of 2 all over 4, right? Find the exact value of sine of x minus y if all of this junk and sine of x is 9 over 41 and sine of y is 7 over 25. This one might look weird to start, but just remember what we're doing. We're working with these all the time, right? So I see sine of x minus y, so we're going to have to follow this one up here. So let me just write this out. If I have sine of x minus y, and I think once I read it out, you'll see what's happening a little better. We have sine of x minus y, and we want to change that into the sum or difference identity, so that's going to be sine of x times the cosine of y minus the cosine of x times the sine of y. That's just following this right here, or this one on the top, sorry. And so, well, we have sine of x and sine of y, right? That's here and here. But how do I find cosine? Well, remember, we have that thing where sine squared plus cosine squared equals 1. So really we have cosine squared equals 1 minus sine squared. We could take the square root. Then we have cosine equals the square root of 1 minus sine squared. Right, so if we follow that, then we can find out that cosine of x equals the square root of 1 minus sine of x, right? 9 over 41 squared. Is there, right? So that would simplify down to, if you put that in a calculator, you would get 40 over 41. And if we did the same thing with cosine of y would have to be 1 minus, what was this number up here, 7 over 25 squared. And if you did those calculations, you would get out to 24/25. All right, so now we have everything we need. Sine of x is 9 over 41 times the cosine of y is 24 over 25 minus the cosine of x, is 40 over 41 times the sine of y is 7/25. And again, if you were to do those calculations, you would come out with negative 64 all over 1025. I'm not going to waste the time going through the calculation. You guys can do that. Or if you just put it into your calculator, negative 0.0624. Right. So again, really the hard part was finding what cosine of x and y are and just plugging it into this for our new formula we're using. Find the exact value of tangent of 285 degrees. Well, again, now we want to do other things, just like the other one. We want to find angles, not that one, this one. We want to find angles that we can work with. And this might not initially come to mind, but a couple that we can work with is that tangent of 285 is the same as tangent of 240 plus 45, right? And if we just translate that into this identity here, if we just follow that along, we would get tangent of 240 plus tangent of 45 degrees all over 1 minus tangent of 240 times tangent of 45. And tangent of 240 degrees is going to be the square root of 3. And again, if you need to, you can do a reference angle of 240 degrees, right? So this is 180 plus 60, right? If this was 60 degrees, that would be 240. 180 plus 60 is 240. So really it's what is the tangent of 60 degrees, and then you could do your 30, 60, 90 triangle. We'll figure out that it's square root of 3, and then we have ASTC. This is T, so it's positive square root of 3. That's how we would do it. And then tangent of 45 degrees is 1 all over 1 minus the square root of 3, right? And so let me just write that nicer. Then we have the square root of 3 plus 1 all over 1 minus the square root of 3. Now, this almost looks like we could cancel this in some way, but we really can't, right? Maybe the nicest thing we can do to rationalize, right? Because we're cavemen, we can't have any radicals in the bottom. Multiply it by the conjugate. And so here we're going to get this thing squared. So if we squared this, we would get 3, we'd get 2 square roots of 3 plus 4 all over 1. The middle ones are going to cancel, minus 3, so really negative 2 in the bottom. And then if we pulled out a 2, right, the 2's would cancel, but we would still have that negative. So really we have negative square root of 3 minus 2. Again, that's all just algebra. Really the new part is this, and maybe remembering to multiply by a conjugate to rationalize might just be a little reminder. But now what I think is the fun ones is verify that this identity is true. Again, probably going to be working with the left side because it seems a little more complicated. And what can I even do to it? Well, I know cosecant is really 1 over sine. So let's do the sine of 3 pi halves plus a equals negative secant of a. Well, and then we also know that we are using sum and difference identities now, so we can probably split that up using our sum and difference identity. So let's go ahead and do that. I'm going to leave myself a bigger line here, and then if we split that up properly, that should be sine of 3 pi halves times cosine of a, we don't know what a is, plus cosine of 3 pi halves sine of a equals negative secant of a. Well, now we can do this. We can do sine of 3 pi halves again, thinking of our graphs is what I would do. I'm drawing them so poorly right now. That one might be better. 3 pi halves is going to be here, so that should be negative 1. So we have negative 1 times the cosine of a, and then plus cosine of 3 pi halves. If that's 2 pi, this is 3 pi halves, so 0 times the sine of a. So really, that goes away, and we have 1 over negative cosine of a equals negative secant of a. Oh, and hey, look at that. If we change cosine back into secant, we get negative secant of a equals negative secant of a. And that checks out. So we verified that identity. Again, I know I went kind of fast, and a lot of it's just kind of algebra and working it out, putting in a calculator. This is the hardest part that we need to get used to. And also on a video, it's hard for me to ask guiding questions to get you there. So I just kind of have to say, hey, 240 plus 45, and then hope that you guys work on it on your own and gain those skills on your own. But that is the end of 7.3.